So now that we have our player ready and we have our ground, the next thing we need to do is build the basic behavior that will empower all the other behaviors we add to the player. These behaviors are going to be things like walk, which direction you're looking in, jumping, anything you can think of that goes on the player. In order to tie all these together, though, we need to create something called an abstract class. And in this case, we're going to create an abstract behavior. Now, we wouldn't want to duplicate all the code we had in simple movement over every single behavior we create. So every new behavior we create that applies some sort of logic to the player will all extend this abstract behavior class. Let's go into our scripts folder and create a new class. We're going to call this abstract behavior. Let's open up the class. And now with the class open, we're going to need to make some minor adjustments. The most important is that we need to denote that this is an abstract class. We'll do that by adding the abstract keyword to the class itself. Abstract simply tells the engine, it tells you, or any other developer working with this class, that they're not allowed to actually instantiate it directly. To illustrate that, if we go back into Unity and we select our player and try to add this component by typing in abstract, you'll see that this component is now hidden from search. There's no way to actually add this to our class, and that's because it's abstract. This is now going to allow us to have every single behavior in our game extend this class and inherit the logic it needs to work without us having to duplicate this over and over again. Next, we're going to need to add some properties that'll be available to all of our behaviors. The first is going to be a buttons array, just like we had in our simple movement. Let's create a public property. We're going to make this typed to our buttons enum as an array, and we're going to call this input buttons. Next, we're going to want to have some private properties that outside classes wouldn't access. But since we intend for this class to be extended, we're going to need to use a new keyword called protected. This allows something to be private, yet available in other classes that extend it. We'll simply write out protected, input state, so we have a reference to our input state, and also we're going to need a reference to the rigid body. So these are the core properties we'll need in any behavior. We're going to need to know what buttons this behavior uses, we're going to need to know its access to the input state, and we're going to need to know a reference to the rigid body itself. Now, in order to get started, we're going to use a new method called awake. Awake gets called before start does on the mono behavior itself. But since we're intending to extend this later on, we're going to make it a protected virtual method. Now, normally you'll see that these are private methods, start and update. Awake is part of the mono behavior lifecycle, but we're still able to add protected virtual, which allows us to override this method in classes that extend it. So this is another good technique to use if you wanted to retain start logic or update logic or awake logic or other mono behavior lifecycle events. You can simply create protected or public virtual methods of them. Here, let's set the input state and let's set the body. Now at this point, our abstract class is done. Let's go back into the scene and quickly set up the input manager and the input state. We're going to create a new game object, and we'll call this input manager. And here we'll add the input manager to it. We're going to need to create two inputs. We'll map these to the horizontal axis. And for right, we'll leave it as greater than. And for left, we'll make it less than. The next thing we're going to want to do is add an input state to our player. Select the player, click Add Component, and if you've already been filtering, you should have input state already there. Now we'll have the default input state for our player. Back in the input manager, all we need to do is drag the player over to the input state property, and you'll now see that the input manager is correctly pointed to the player. We can save our scene and get ready to build our first behavior.